So hi, this is the top 5 things you should know about databases on Kubernetes versus VMs. And I don't know that we actually have exactly 5, but I'm pretty happy with the things that we've come together. So briefly, what we're going to talk about, and I want you to feel like this is your session because you are here, this is your time. This is an amount of things that we put together, and we're happy to answer questions online or in person. Well, I guess online. But there's definitely not an hour's worth of material here. We'd love for this to be interactive. Super briefly, I don't know if Rachel and then Adam want to introduce themselves, but go ahead and give it a try.
I'm Adam Berlin. I'm an engineer at VMware working with Postgres and Kubernetes.
I'm Rachel Heaton. Same.
Same.
And I'm Marco. I'm a product manager on Tanzu SQL. Our goal, we're Kubernetes people, and we are learning more about VMware and vSphere over time. And I think one of the goals for us in our talk was to learn and prove out some things that we had always suspected was true. Yeah, okay. I will mute myself when other people are speaking. We wanted to prove some things out to ourselves, and we figured as long as we were proving them to ourselves, we might as well share what we've learned with the community. That means you all. So happy to go through what we've learned in the last few weeks while we're preparing for this. But mostly what we wanted to do is make people who are feeling Kubernetes cautious to give some confidence that Kubernetes has come a long way. And we're happy that we're making good progress. And then I think another goal that we had in this is to demonstrate a few things that Kubernetes is good at. Because what we'll try and touch upon a few times in here is that I think a lot of people think that Kubernetes is just another container resource manager. But in fact, it's a lot more than that. And so we're going to try and sneak a few things in to explain and show why Kubernetes is more than just ways of running things inside of containers. If you are here because you're looking for hardcore performance testing and analysis, we did not get to that today. It's something that I think would probably soak up an entire talk. So that's not the goal of this one. The goal is, you know, hey, if you are running on VMs, we're going to compare a little bit against VMs and Kubernetes, and then show some nice things. Just briefly, it's always good to have a definitions page. In this case, I only came up with 4 definitions, but I bet you there's more terms that will sneak in. I'm certainly not going to try and cover what a CRD is in this talk. But especially because cluster means different things in different contexts, I thought it was important to lay out that on vSphere, a cluster is a set of physical hosts which can run VMs. And in Kubernetes, a cluster, at least in our case, a cluster is a set of worker VMs which can run containers. And so if I use the word cluster in different contexts, feel free to ask me in the chat or other ways to explain what the heck I'm talking about, because we're going to be going back and forth between vSphere and Kubernetes frequently. And I don't want to confuse you and leave you behind. That's not the point. A virtual machine, a VM, is a virtual machine that runs on top of a hypervisor. In our case, we're using ESXi because VMware. And the virtual machine is running a guest OS. I think in all of the examples, we are using Bitnami's distribution, an OVA, Bitnami's distribution of Debian running Postgres. And then a container is not a VM. It is a set of processes isolated from the rest of the system, which I really like the very formal definition. And that means what we'll be doing is we'll be running these processes which are distributed by containers. And in our case, I'm sorry, container images. And in our case, we're using our own container image because that's what we build for a living. And it seemed like easiest for us to demo our own stuff. So this is not a product talk. We're not here to sell you anything, but we are using our product in order to do the demo. So I hope that's okay. One of the things that made this really easy is that internal to VMware, we have a hardware as a service platform where you can ask for pre-configured and deployed instances of VMware or vSphere or Kubernetes running on top of vSphere. And so that made it nice for us to control our tests a little bit in that we're using exactly the same hardware in both cases. We had a Dell PowerEdge dedicated to being a single vCSA host, which took all the physical resources and made it available to VMs. And then we had another identical host that had Kubernetes deployed on top of it. And then in order to make this demo work, we deployed 6 worker VMs. I should have said VMs in this page, each of which had a certain amount of capacity on it, which is then being orchestrated by vSphere under the covers. So that's kind of a tricky thing. I wish that we could have deployed containers directly onto hardware, but that would be a very different talk and much more focused on performance, and that's not what we're trying to accomplish here. So the most important thing, I think, for the folks who are Kubernetes cautious is to really point out what's similar. And it turns out, as we did our research, as we did our preparation for this talk, a lot of the characteristics are a lot more similar than I had expected. And if anything, it continues to raise my impression that as a resource manager alone, vSphere is really impressive. So let's take a look at some numbers real quick. We'll talk about this at the end of the talk as well, but vSphere is hyper optimized for speed, and so it does a bunch of things in order to speed things up. So creating an OVF like the one that we download from Bitnami, which is a VMware property, to deploy Postgres takes 27 seconds to create a VM from an image and deploy it and boot it. I have to admit that I did not figure out how to properly time power on to login prompt, which is when Postgres is actually up and running. So some of these things are a little bit flexible in that I guessed as much as I could from looking at the vSphere console. Another way of creating a VM is to clone from an existing one, and I have a screenshot of that later on in the slide in the deck. That can take anywhere from 15 seconds to 22 seconds. I'm not sure what the variability was because we didn't have anything else running on the system. I'll just briefly interrupt myself because I see in chat. I do not know how to run a container on a type 1 hypervisor, although I think what we're actually thinking, now that I think about it, I believe that what we're really talking about is a form of TKG, that's Tanzu Kubernetes Grid, which is built into vSphere itself as of vSphere 7 update 2, I think, where vSphere itself has both VMs and containers built into it. And so you can deploy containers on native vSphere right next to and parallel to VMs, and vSphere is managing all of it. So that's probably the closest that we can get to for a type 1 hypervisor, but I don't have anything here to present. Good question, though. And then finally on this slide, returning to this slide, for our Kubernetes operator, and I realized I forgot to label VMware or vSphere, but on this green column, this is vSphere, so embarrassing goof. Let's hope that's the worst. There is no ability to expand HA because vSphere doesn't coordinate across VMs in the way that an operator would on Kubernetes. And so maybe this is the first time for us to slip in a little bit of difference. For vSphere, we're deploying lone VMs manually, and you'll see where that was a bit of a holdback for me in producing some of the slides for here. But that also means that you can't easily produce complicated technologies without resorting to other more complex features that are offered by VMware. So I didn't have the ability to time how long it takes to expand a single node to a high availability cluster, but that is a feature of our Kubernetes operator. So on the right-hand side, you can see it takes very similar time. And honestly, we thought that Kubernetes would blow vSphere out of the water here because we're used to being able to throw away and create hundreds of containers in seconds. But vSphere is crazy fast. So at least you know that Kubernetes is comparable in creating a pod. And a pod is a term for a container or set of containers that are deployed on Kubernetes worker nodes, and that it can increase CPU in the same way that vSphere can. The good news is that throwing away and recreating a pod in order to increase CPU is really light touch, whereas in order to do it on vSphere, you do have to have it, I'm pretty sure you have to have it powered off. So the reconfigure step in vSphere is 103 milliseconds, and then another second for power on, and then however much modulo time to reboot and get to prompt. It's an online operation in Kubernetes for the infrastructure that we were using. And I believe your mileage will vary, so it's my job to say that these are totally subjective timings that we did using exclusively these internal things. For the question about increasing CPU, yes. So I think I didn't write it down here, but what we did was we increased the CPU shares on the Kubernetes side, or the vCPUs on the vSphere side. And I think I went from like 2 to 8 on vSphere, and probably 1 to 8 on Kubernetes. All right. So one of the most important things that we were hoping to get across in this talk is how, not necessarily how large a VM or a container can get. I think everybody's really focused on, can I make my database really big? But what we wanted to focus on today is it's extremely happy that Kubernetes is really, really efficient at making things super small. And so one of the things we were hoping to prove to ourselves and share with you is we believe that because there is no overhead of the operating system in a guest OS, because containers are just shared processes that are sealed off, you should be able to do two things. First of all, you should be able to make containers that are much smaller than you could possibly with a VM, because you don't have to make space for an operating system. And you should be able to pack a lot more of them into an existing instance. So why don't we go through some of our experience results? And I'm not in any way going to defend this. This is our experiment in order to inform ourselves, and if it's useful to you, that's great. I am not about to have this published in a peer-reviewed journal. I don't think that was our goal here. So one of the things that I need to cover before we talk about that is vSphere, again, is set up to do everything it can to make the most efficient use of resources possible. And I think I have a couple slides that will cover this in more detail. But what was really important for the purpose of this talk is to follow the best practice of forcing vSphere to not overcommit, so that we could make sure that the database instances that we were creating are appropriately resourced, and that we could understand the true limitations of the system. So in this case, I just took a quick screenshot of what happens when you turn off, or rather I should say, when you pin vSphere to providing full RAM capacity for each VM that you create. And that is eventually you get to the point where vSphere says you can't do that anymore. What's really interesting is that, and one of the things that made this challenging, so full transparency around Kubernetes, is that Kubernetes gives you a clear answer like this. Instead, as you start to ask Kubernetes to schedule more resources than what you have, Kubernetes is even more cloud native than vSphere, in that what it will eventually tell you is, I'm not able to schedule this load to any worker nodes. But it will continue to try and converge forever. So it never just says, no, I can't do this, I'm sorry, go add capacity. It says, you, the operator, are trying to deploy a bunch of things. You must care about those things. If I tell you that I can't schedule them, go add more resources, and then I'll go through and I'll follow through with the thing that you asked me to do. And that came up later on in this talk. So really briefly, and then we'll come back to vSphere in a few minutes. If you were to try and prove out the point, but also for practical uses, like if you were trying to do a lab or a class where you needed a whole bunch of identical instances, we found that it is really, really easy for very straightforward, I should say, it's really easy using the Kubernetes primitives that are supplied as part of Kubernetes to do things in a very repeatable manner. So for those of you who've never seen Kubernetes before, this is on the left what we do in order to tell the operator, which is a piece of software running on the system, not a human being, to tell the operator that we would like to create a Postgres database. It's a heavily reliant on YAML, but we do everything we can to minimize that YAML as much as possible. So I'm just going to walk through this super quickly because I made a goof and I want to be fully transparent. In order to create the instances and really bin pack as many instances as we could, functional instances on our Kubernetes deployment, I constrained the instance down in exactly the way that I was describing earlier. So each one of these containers only has 200 megabytes of RAM, not gigabytes, megabytes. And in fact, and I'm sorry, I took the wrong screenshot, so I didn't want to fix this afterwards. In order to make sure that Kubernetes could actually schedule all of these, I actually used 4/10 of a CPU. I think these are called milli-CPUs. Kubernetes has some really advanced abstractions so that it's not infrastructure specific. So you can talk about things in fractions of CPUs or multiples of CPUs. And in this case, we wanted functional databases, but we didn't want to give them a huge amount of capacity so that they could all coexist on the same infrastructure. And then I only gave them 250 megabytes of storage, again, not gigabytes, which allowed me to go ahead and stamp out a whole bunch of instances. And the nice thing about Kubernetes is because it is a declarative nature, meaning it's constantly trying to reconverge on what you requested, as opposed to being what exists now is the source of truth. What I was able to do on the right-hand side is, and I don't know if you're super into shell scripting, but I think that this is kind of easy, is to say, hey, look, I have a template of YAML that I would like to do where I'm just going to name everything Postgres single node XX. For 50 instances, please replace, I guess 51 instances, replace that XX with a number and render me out a new YAML file to do that. And as a result of this one command, what I get is a bunch of YAML files, 0 through 51. 0 through 50. And then it's another command where I can tell Kubernetes to go ahead and apply every single one of these, and it will figure out how to create all of these 200 meg, 250 megabyte instances. And the result looks like this. And so again, this is a great place to stop and briefly share one of the things that makes us geek out about Kubernetes. As authors and people who are making deployments, you can label deployments in a way that is very common with resource managers going on way back. So when I have a whole bunch of things running on a Kubernetes system and I'm preparing for a share out at Percona Live, for example, I can tell Kubernetes to only show me the pods that are relevant to us. And in this case, I can also show you what I'm hiding. And one of the things that made this prep challenging, honestly, my goal was to deploy 100 instances so that we could really impress you about how much we could do on exactly the same hardware. But because our Postgres operator is programmed and planned to go all the way through to production, for every instance of Postgres we deploy a container alongside it that is called the Postgres monitor. And it exists so that you can take any one of these Postgres deployments and upgrade them to HA seamlessly. But of course, that had a cost on my infrastructure footprint. And so I was only able to get to 50, which is fine, because I think that this proves the point regardless. And so what I wanted to show you and stress is this syntax we can do. I can get the pods, but I can specify a selector, only show me the ones that are deployed by the Postgres operator and labeled Postgres. And then because I think you all only care about the number of databases, you don't need to see our internal stuff, exclude anything that's also labeled monitor. And then briefly show kind true makes this easier for you to see that these are pods, and each pod can contain multiple containers. But in this case, I just wanted to show you the status of the pods that is actually running the databases and prove to you that we were able to plug all this stuff in. Okay, deep breath and a sip of tea. I'll come back to bin packing in a few minutes when I get to what we learned. But let's move on to other things that are true. One of the bigger things that I've seen folks concerned about is how elastic is Kubernetes. And can I be totally flexible? So let's talk about storage briefly, because I think that's another area that's very interesting. I already briefly covered expanding on CPUs, and the same thing is true for memory as well. For hard disk, there's any number of layers of virtualized storage like vSAN, or any number of physical SAN products where you can reconfigure the storage on the fly. And in this case, I'm saying, well, I want to take this thing that has, I think it had 2 gigabytes of disk space ahead of time. I want to recreate that with 20 gigs or expand that to 20 gigs. And that works fine. And I'm really happy with how amazingly flexible it is that vSphere can connect to anything. And it's worth pointing out that among the optimizations that I was talking about, which I was really kind of daunted by when presenting this and realized we're never going to get to like a hardcore performance analysis, is that these devices are like thick provisioned but lazy zeroed. Any number of deployments in between. Our Kubernetes storage itself is thin, so the storage guarantee is less solid than the CPU and memory, but that's just because I'm using an internal development only environment that's not hooked up to a quote unquote real storage system or a real production vSAN. But the good news is that Kubernetes can resize storage too, and it's pretty easy to do. So briefly, I just want to do a quick time check. Okay, we're fine. If we look at a pod that I had running before, or a deployment that I had running before, this is one of the 51. And I look specifically at the Postgres container, again, not the monitor. And I ask for the disk space on this system. We see that it has a gigabyte assigned to the Postgres volume. And the reason for that is actually kind of clever. In order to do this, I had to go to a more elastic environment, and I'll show you what the downside of that is in the next slide. I did this on Google Compute, on the Google Compute platform. And what's really interesting is you heard me saying that I wanted to make everything minimum, and didn't I say 250 megs? And that's true. But in order for them to manage their storage in a way that makes sense for them, that is scalable, even if you ask for 250 megs, it turns out you get 1,000 megs. And so in order to make this demo worthwhile, I had to go from 250 megs to 2 gigs. If I went from 250 megs to 1 gig, which was the first iteration of this slide, these two numbers didn't change. And that's just because that's what works for Google in order to scale and serve their audience. So it makes sense for them to round everybody up to the nearest gig. The neat thing about the declarative nature of Kubernetes, kind of coming back to this, is when we want to apply or patch a change, all I have to do is change the definition of 250 megs to 2 gigs, and then run an apply command using the same file that we used originally to deploy it. And Kubernetes will go ahead and make that converge on the new deployment. So as I waited for a few minutes to watch this take effect, later on, I was able to come back and do the same command that we did before, where I asked to log on to the Postgres container and do a df, and we can see that the instance, the number of blocks has changed. And then I'm also gratified to know that we're now using half as much because our storage system is twice as large. I'm going kind of slow on purpose because I don't know or assume that you all know a lot about Kubernetes. But I'm hoping that these things are maybe a little pedantic, but very useful to understand the way that Kubernetes works. Now, there's a downside to this, in that Kubernetes works really hard to provide abstractions across lots of different infrastructures. So there are times when that shows through. So again, on my internal dev and test vSphere deployment, the storage line that is provided on my physical hard drive, on my physical nodes that I was talking about earlier, the Dell Power Edges, that doesn't work. And so if I try and make a change, in this case, Kubernetes is not going to try and converge on something that is never going to work. Instead, it does give you feedback information, so that when you look at the thing that you tried to do, it'll tell you automated resizing of a PVC is not supported by this storage storage class. And that's fine. You just need to be aware of where you're deploying before you try to make changes to a system. So just make sure you know what infrastructure you're deploying to before assuming things. Okay, deep breath. We talked a lot about bin packing. We talked a lot about changing. One of the things that we also really wanted to include in this talk is that there are things in the Kubernetes ecosystem because of the way that Kubernetes works. Now, you remember I talked about labels a few minutes ago, such that the community is now able to provide things that used to be kind of more the purvey of software vendors. And a really great example of that. So we have a lot, we have a lot that we would love to be able to demo, but in terms of like just getting the magical phenomenal power of what the community can do, we thought that adding monitoring was a really good example of how you can get stuff for free. So where in the past as a product manager, I had to work with teams in order to build out monitoring systems and make them scalable and all this stuff. In the Kubernetes world, as part of the CNCF, or the Cloud Native Compute Foundation, the community, there are now things that plug into Kubernetes so that with relatively little integration effort, you can ask for stuff for free, or not ask for stuff, you can include monitoring for free without doing massive reconfiguration or custom building. There's a question on the chat about Kubernetes logging, and I'm so glad that you mentioned that. Yeah, it absolutely does, and it's pretty easy to type kubectl logs on the command line. But what's really great with this example that Rachel was able to pull together for us is you can integrate Kubernetes standard logging, and we spend a lot of time making sure that when we do our logging internally, that we're doing it in such a way that Kubernetes can see it, so that that information can be routed to an Elk stack, or in this case, a Grafana stack, a Grafana and Kibana stack. So what you can see, and I'm sorry that the screenshot is so tiny, but we just didn't have the ability to make really large images, but always feel free to follow up with us offline, is that by doing the steps on the left, plus a little bit of tweaking, which we can make public in terms of how to automatically create these nice dashboards, we are not only able to automatically capture metrics. Like you notice that I didn't do anything to say, hey, I've got some Postgres out there, go find it and then use it. It knows based on the fact that we are deploying Postgres instances and we're adding a Postgres exporter to find anything labeled Postgres and start collecting data from those things. So on the lower side, you'll see that we have node metrics as well as database metrics. But on the upper side of this, you can see super tiny logs, both for a Postgres instance and for a Postgres exporter itself. So all of these things are being piped through the system, and anybody can consume them, including Grafana or Prometheus. And all of these things, I want to just briefly walk through the steps. All of these things are publicly available, and you can just layer them into your system as you go. So you can do a Docker pull from Prometheus community. You can add the Grafana Helm repo, and Helm, if you're not familiar with it, is one of the several ways out there of kind of automating the templating and deployment of software so that you don't have to be an expert in order to download and run things. So Helm is a great way of doing that via the public Helm charts that are available from Grafana and Prometheus. And then the commands to actually deploy the software is helm install, helm install. VMware, we also use a tool set called Carvel. If you're really interested in learning a lot about YAML templating, please check out our open source project. It's a big thing that we're working on, but for the purposes of this is the easiest way to demo. And poof, monitoring works. And that works for any one of our 50 instances, but we didn't want to death by PowerPoint, so we only have the one slide to demonstrate. All right. So we've talked about sizing, we've talked about monitoring, we've talked about CRDs obliquely, we've talked about labeling. One of the things that's really great is that vSphere and other VMware infrastructures are really, really good about being a bulletproof platform. And Kubernetes is also a very, very smart resource manager. So we thought we would give a couple of videos. And this is definitely a more experimental part of this. So if the videos don't work well, they are on YouTube, and I'll provide links later on. But rather than doing a live demo, we thought it would make sense to provide some or illustrate what it looks like to do things. So I'm going to try and full screen this if I can. Oh, maybe I can't. Pause, mute, full screen. That's not going to work. Let's see if switching to YouTube will help. That blows us out. And we go back to full screen. Now I think you can see this better. So what you have on the left is the Google Cloud Platform viewer. And you can see that we have a whole bunch of stuff deployed. We have the Redis that is used to back this little database monitoring app that I have here. It doesn't make sense to record your state around database availability in a database. You need another place to put it. Redis is a perfectly fine data store for this use. So I have Redis deployed on Kubernetes, and that's actually in an HA configuration. We have Grafana and Prometheus, just like I talked about. And then all the way down here below the bar, we have PG single node, and I'll mention that. And the app as well is all deployed on Kubernetes. And so what I want to do here is show you what a single node looks like, so that from a naive app point of view, how do we leverage and what is the timing for Kubernetes to notice that something has failed and replace it with a new instance of that thing. So what we're going to do is, and this goes really fast, it's only a 40-second demo. Shoot, I guess I gave away the answer there. Is we're going to find the single node container that is running Postgres, delete it, and watch Postgres and the app work together. I'm sorry, watch Kubernetes and the app work together to recover from that. So there's the monitor that I told you about and was hiding in the past, but we're going to delete the Postgres container, delete that, and you'll see that the container goes away. And so my app is not able to connect and is able to record its data in Redis, saying, I'm not able to see it, I'm not able to see it, I'm not able to see it. This is real time, it's not sped up. But due to the really, really lightweight nature of a container, especially because it's already running, it already has run on our worker VMs, you'll see that within, what, 5 seconds? The app is back online and we're able to work again. This is really nice because there's no high availability characteristics. We're just relying on Kubernetes to be the resource manager and understand when something has failed. Okay, I think we're back to my slide deck. So that's what it looks like for single node. And one of the things that's really important that we want to stress is that when we talk with commercial and enterprises that are running at scale, the first thing they want to ask about databases is what is the high availability characteristics? And we say, we do spend a lot of work on high availability, and we'll prove that to you in a page. But really, when you're starting to use things that are super lightweight and super cloud native, maybe you don't need to be so pedantic about high availability everywhere, because you can trust the platform to do things for you so that DBAs don't get paged in the middle of the night when a VM or a hardware, a physical computer goes down at night. But because we all, oh, why did this drop me out of presentation mode? Well, that's okay, because we're going to go to YouTube in a second. But if you did want to see what high availability looks like, we also have a demo for that. And the nice thing about this demo is we are part of the Postgres community at VMware, and we are contributing to an open source project and collaborating with Microsoft on developing something called PG auto failover. And actually, before I get into my whole on product pitch, well, it looks like Rachel and Adam are covering some of the items in the chat. So I'll continue to focus on the demo, and then if we have time left over, we can also answer things live. In this case, what I'm going to do is we're going to show you how we choose to deploy PG auto failover as part of a Postgres cluster on Kubernetes, and watch how the two interact together so that we can minimize impact to applications but still leverage the auto-healing characteristics of Kubernetes. So let's take a look. Okay, so what we have here is a little bit more complicated setup because we're running in a HA environment, and you see Octant, which is another community project that we're contributing to in the Kubernetes community. You see the visualization of all of the resources that are necessary for a HA deployment, and you can also see why I'm like, man, you should only use HA if you really need to, because you're introducing a lot of complexity. You can see the monitor client in the upper right, and you can see on the left, we have the Kubernetes view of what it looks like. So you can see the three database nodes, which each have dedicated storage behind them, persistent storage. And in this case, I forgot. This is actually a demo for MySQL. We do Postgres and MySQL equally, and I forgot that I wanted to include some Postgres and some MySQL. So in this case, we're running an InnoDB cluster, running group replication as our form of HA, but PG autofailover group replication, equivalent-ish technologies, same effect. So we're still going to get to see how Kubernetes works. And in this case, I'm validating that DB0 is the primary so that I can go ahead and do some damage. What we're going to do is we're going to actually just delete the pod entirely. And you'll see that my app notices right away, like, hey, I can't connect to my database. But within the period of time it takes to complete the sentence, the app is able to reconnect automatically to another host. And you'll notice in the upper left and in Octant that Kubernetes will notice that I have damaged the cluster and immediately go into damage control mode, where it recreates the container that has been lost, automatically adds it back to the cluster, and then PG autofailover in the case of Postgres and group replication in the case of MySQL will automatically merge that back into the cluster. And in this case, that whole process of losing the container, realizing the container is gone, bringing it back into the cluster, and then making it a part of the nodes so that it's up and running takes about 38 seconds. And this is great because at no point does anybody get paged. At no point does anybody have to log in and check like what happened in my cluster overnight. It's all automated, and there's no proactive repair that needs to get done. Okay, let's go back to presentation mode if I can. I don't want that. Present. Having some technical issues. Well, this is going to have to work. Okay, so we're kind of in the end run now. We'd love to have more time to prepare for you lots more juicy stuff, but I think that this is probably pretty good for now. But I would love to share with you what we learned, because honestly, this is something that Rachel, Adam, and I just wanted to prove to ourselves. We want to understand the systems that we build on better so that we can best highlight their advantages. So one of the things that came up, and this is definitely something that old-time infrastructure people are going to be really familiar with, VMware made its name on improving utilization of hardware resources by packing virtual machines onto physical machines. But what we see through doing this is that Kubernetes is really good at leveraging that, because what we did is we took 6 physical VMs and we packed 50 database instances onto those VMs. I know I said physical VMs. 1 physical host, 6 VMs, 50 deployments of containers on it. And you can see in the right that CPU and memory utilization is way higher. And coincidentally, we have the exact same number of virtual machines. So in order for this to work, there's a number of virtual machines which are necessary in order to run Kubernetes itself. So where does the master controller live? Where does etcd live? Blah, blah, blah. As well as the 6 VMs that I'm referring to that are worker nodes. And oops, on the right-hand side, on the left-hand side, pardon me, we happen to have exactly the same number of VMs. And that's totally coincidence. You remember very early in the presentation, I said that I was cloning VMs in order to get to the point where I could show you when we run out of physical capacity. That result, in addition to a DHCP server and little things like the VCSA, came out to 20 nodes as well, 20 VMs as well. But you can see that the CPU and memory utilization is very different. So again, I think everybody is able to prove out that VMs and containers can get very large. And I don't know if you've seen recent releases of vSphere, but they have a mega VM feature now, where you can produce many cores and many gigabytes of RAM in a single VM. And that's something we'd like to follow up as well. But the purpose of this talk was to show what happens when you go tiny. And I think we really proved that out. But I also wanted to call out that being fair is really hard. So there were things due to the way that vSphere works and in the amount of time that we had to prep for this that I think we probably could have done better. So one of them is that I'm not an expert in vRealize or other forms of vSphere automation. And so in order to create the containers, you saw that I was able to do some quick sed scripts on on YAML. But for deploying on vSphere, I was using the cloud dashboard, and I was using the clone feature. And clone is pretty fast, but you have to make sure that you're setting vSphere up for a fair comparison. So you have to set on the right, and I said that I would share this with you, how you do this, this reserve all guest memory, so that there's no possibility of memory or CPU steal if you wanted to tune in that way. So that as we deploy dedicated instances, we're actually getting dedicated resources for each. And in order to do that and finish the presentation in time, I only ended up creating 16 VMs with 2 gigs each. And I'm quite confident that if we really worked hard, we could get vSphere to have comparable behaviors to Kubernetes. But I think the point of this talk is not necessarily to point out, oh, Kubernetes can beat vSphere, although as we continue to refine and make improvements, I think we probably can show that based on my assumptions around guest OS overhead. But we can show you that if you're worried about Kubernetes or considering Kubernetes, that I think we've done a good job of showing that they are equivalent, and you can get the same sort of resource utilization, if not necessarily performance. That's another thing to do. So super briefly, where would we like to go next? Or if you are a part of the community would like to pick up where we left off, we'd love to continue to refine making really tiny instances work and be scalable, because I feel that for every big, very attention-getting production database where people are super concerned about performance, there are hundreds or maybe even thousands of databases in dev and test. And as we convert to being more of a cloud-based deployment, that dev and test footprint can get really expensive. We have folks who are running thousands of VMs in production. We'd love to be able to reduce their footprint cost by moving those to lightweight containers. But at the same time, I don't believe that anybody wants to run a dev and test environment that doesn't have the capacity to perform in production. So we would love to be able to demonstrate how to create really large instances. And then I think the real challenge, and I don't know that this is an area where I really want to go, I think that there are other people who have more specialized skills, is understanding how to better tune both vSphere and Kubernetes, both at the resource management / CPU memory level, but especially at the storage layers, so that we can really begin to dig into whether or not the cost / overhead of virtualization is comparable to the cost / overhead of containerization. But I think that's something that I think the community is probably going to continue working on, and not something that we really need to focus on. So it's been about, it's been about 45 minutes. So I wanted to say thank you and give you a few links that are more information about our stuff. My co-PM and I, Judy, did a Tanzu TV where we covered a bunch of features of Tanzu SQL Kubernetes operators, both MySQL and Postgres. Also, the demos that you saw today were a couple. One of them we shot for this presentation, but the HA demo just came out of our demos playlist. So if you wanted to see more about how we're deploying and managing and updating and creating, connecting applications to databases, you can see these things as well. And then finally, the product page, if you're interested in learning more, and you don't have to, but we'd always be happy to hear from you, is on tanzu.vmware.com. And I wanted to thank Percona for putting this together, because I love Percona Live, and I can't wait to go back in person someday. But we'll do what we can online, and so I'm happy to be a part of that. And thank you. We have 10 minutes. I'll stop sharing my screen, and happy to sit for the next 10, 12 minutes online in case you want to have more conversation and chat.